Continuing with our questions. We have this car, and it starts from rest, and as it passes this marker, it's at 140 miles an hour. So when are we going to acquire a speed of 70? Let's be clear. Since we have uniform acceleration, it's going to take more time to speed up to 70 than to go from 70 to 140. For choice C. Here. At time t, the truck will have definitely traveled further in the car. The reason we know that is the area of the graph is bigger for the truck. All right. Continuing on. Number 7. We want to know the acceleration while towing the van. So it can give A on its own. So the force is ma, this net force on it. And now we have 3m when we want to know what A nu is. So that ends up being a third. Here. Heavy and light balls falling. P and Q are dropped. No. They will actually reach the floor at the same time. Let's talk about the reason. The gravitational forces are not equal. The ratio of force to mass is the same, giving us the same acceleration. And then here, we're going to actually have zero force at the midpoint of motion, where we are in equilibrium, which is where the net force is 0. All right. And then here, when the string snaps, we're going to go off tangent to the circle, path 3. All right. Now let's conserve momentum here. So we have 3mv to start with, and the final momentum, so we have 2m at 0 and m at v final, and that ends up being 3v. Here. We want to know what the speed will be at Q if we take path 1 versus path 2. So it actually turns out in the absence of friction, we just have mgh equals 1/2 mv squared. We don't care how we get there. The speed will be the same for both paths. There's this trick here. They want you to think that the dip matters, but it actually doesn't. Sure, it's faster down here, but then it slows up. It slows down going up so that its speed at Q is the same for both. All right, so that finishes up the multiple choice paper 1 section of our exam. And I will go ahead and begin the free response paper 2 and paper 3 questions in the next set of videos.